Okay, this is an experiment. I'm going to use 3 slides on this one. This problem number 1A, you see on this slide. Okay, we'll see how this goes. Now, problem 1 says, what is the solution of the system? Use substitution. In order to use substitution, we need to, if you remember correctly, isolate a variable. So I'm going to take this equation and I'm going to isolate y by actually, instead of moving 3x to the other side and then dividing by -1, I'm going to just add y to both sides. Add y, and you get 3x equals y. That's the same as y equals 3x. Okay? So now that we've done that, we then take the other equation, 8x minus 2y, sorry about that, equals 2. And we're going to substitute for y, we're going to put 3x in because that's what y is equal to 3x. So 8x minus 2 parentheses 3x equals 2. And then that's the same as 8x minus 6x equals 2, or 2x equals 2. Now dividing by 2, we get x equals 1. That is part of our solution. Okay? And we will then be able to use that to solve for y. So we can take either equation. Let's take 3x minus y equals 0, it says. Oops. Sorry, I just want to make this a little bit neater. And now we're going to substitute in 1 for x because we found out that x is equal to 1. And we get 3 minus y equals 0. Adding y to both sides to isolate it, we get 3 equals y. And we believe we found the solution. What would be the solution? It would be 1, 3. How do we check it? We substitute both of the variables in to check. And I'm going to do that, call it the proof. First one we'll do 8x minus 2y equals 2, and then substitute in for x and for y what we believe they are. And what do we believe they are? 1 for x, 3 for y. And simplifying it, we get 8 minus 6 equals 2, or 2 equals 2, check. Now we're going to do the same thing again with 3x minus y equals 0. 3 parentheses minus parentheses equals 0. And we're going to sub in those values. 1 for x, 3 for y. And we get 3 minus 3 equals 0, or 0 equals 0. Check. So we have as a solution 1, 3. So for 1b, we're using substitution, and we have an equation that says x plus y equals 2, which seems really easy to isolate one of the variables. We can do either one, and if we took, let's take away y, so we could say minus y, and we will get x equals 2 minus y. Or another way of writing that would be x equals negative y plus 2. As long as the 2 is positive and the y is negative, then it doesn't matter where it is. Okay? Now I'm just going to use the first one that I got. That one's fine. And I'm going to substitute that in. So we can take 7x plus 5 equals 0. And then we say 7, we got x, what x is equal to, so I'm going to put parentheses there, leaving a little bit of space, obviously, to be able to fit it. And that x was equal to 2 minus y. Okay, so when we distribute that through, we get 14 minus 7y plus 5y equals 0, or 14 minus 2y equals 0, adding 2y to both sides. We get 14 equals 2y, and I'm running out of space here on my pad, I'm sorry, so I'm just going to write 7 equals y. You can see that I would divide both sides by 2 there, but I ran out of space. You should be showing that work, I just couldn't. Okay, so that's what we believe y is, and now we need to find out what x is. So I'm going to take the simpler equation, just seems to make more sense to me, and say x plus y, sorry about that, x plus y equals 2, and substitute in 7 for y. Notice that I did not go and use my modified equation that I got here, x equals 2 minus y. If I made some mistake somewhere, checking it in the mistake might not, the reason that I got the wrong answer might have been because I made a mistake here, and then it'll work in there. The wrong answer will work because I didn't have it the right thing that I should have. So if I made a mistake, it wouldn't show up if I used that, but it would show up if I used the original one. So we always go back to the original one. And you substitute in, what is y? Y is 7. So now we have x plus 7 equals 2, so I'm going to subtract 7 from both sides. I'm going to get x equals negative 5. Seems to be the answer. Okay, so what am I going to do? I'm going to substitute both of the values in for each equation. So we get x plus y equals 2. And actually, let me write the word proof so we know what we're looking at. Proof. X plus y equals 2. And then we'll put in those values. What are they? We've got 7 for y and negative 5 for x. When we resolve this, negative 5 plus 7 equals 2, so 2 equals 2. Check, works out. And we have another proof. Very difficult to write with this. My apologies. If I put my hand down like I typically would, I'm going to make marks and it's going to throw the whole thing off because it's reading my touch screen, as you know, if you've ever written on touchscreen. So sorry about that, and it's a little awkward. Now 7x, the other equation, plus 5y equals 0. Excuse me. Same thing again. Put parentheses where we're going to substitute in the values and plug them in. X is negative 5, y is 7, and when we simplify this, we get negative 35 plus 35 equals 0. Or 0 equals 0. Check. Substitution. It's great. And actually, I want to just write our ordered pair as a final thing to show what our answer is. Okay. equals 6. And now we're substituting for x, so I say 10 parentheses plus 7y equals 6. And what are we substituting in there? You're substituting in negative 2y minus 2. So then when I multiply this through, I get negative 20y minus 20 plus 7y equals 6. And combining like terms, what are the like terms? Like terms is this y term. It's got a y on it. This is just how many there are. There are negative 20 of them, but this is what it is. They're y's. And this is a y term as well, because that's what they are, y's. How many of them there are? Positive 7 of them. So we can combine them to be a negative 13 y minus 20 equals 6. And of course, we're trying to move all the constants to one side and all of the variable terms to the other. Constant is something that doesn't have a variable attached to it. This negative 20 is a constant. It's always worth negative 20. Whereas this is a variable term. This isn't worth negative 13. This whole term isn't worth negative 13 unless y was equal to 1, because negative 13 times 1 would be negative 13. But if y is anything else, then we're multiplying negative 13 by something else other than 1, and it's not going to be worth negative 13. So we don't say that this is constant. It's not constantly worth negative 13. It is a variable term because it varies or changes depending on the value of y. If you don't have your mind around that, you really should get your mind around it. It is so fundamental to mathematics, all of the math you'll do for forever, that if you don't understand the difference between constants and variables, then you need to basically tell someone, help, I don't understand the difference between constants and variables. My math teacher's telling me that I really need to express concern and tell somebody. Okay? I can't stress that enough. If you don't know what someone means when they say a constant, don't let it go any longer. Okay? That's me telling you to panic if you don't know. And what I mean by panic is don't panic, go get help. Okay? Now, we need to get the constants to the right-hand side, and that negative 20 on the left-hand side is the constant. So what are we going to do? We're going to add that amount to both sides. We're not just moving this over. We don't say we're moving that over. We're adding an equal amount to both sides so that it gets canceled out there. Okay, but we don't just grab it and move it. That's not how it works. Now, negative 13y equals 26. And of course, we're always dividing by the number in front of the variable, the coefficient of the variable. And please see the negative as well. I hear people all the time telling me, divide both sides by 13. That is not 13. That is negative 13, and they are different numbers. So get that straight too, because a negative number is not the same as a positive number, so you shouldn't be seeing the number 13 there. You should be seeing the number negative 13. That's what's in front of the variable. That's what we're going to divide it by, and we're going to do the exact same thing to both sides because we need it to stay equal. And when we do that, we get y equals negative 2. Great. So now what do we want to do? We want to take the other equation that we haven't yet, or either one of the equations, and we want to solve for it. I'm going to take the simpler one now. So I'm going to go back over to this empty box here, and I'm going to solve it over here. Okay, so I'm going to write negative x equals 2y plus 2, and we know what y is equal to, so we say negative x equals 2 parentheses, it's equal to negative 2, so we're going to write in there negative 2. And we're going to solve this out. So we say negative x equals negative 4 plus 2, or negative x equals negative 2, and then we need to divide both sides by negative 1, and we get, I'm running out of room here, and we get x equals 2. Now, for the sake of time, I am not going to do a proof. You should. You should do a proof for both of the equations and be sure that you are doing this right. So I'm going to just say this, since I'm not going to do a proof. I don't know whether I got the wrong answer. There's a possibility that I did. I don't believe it I did, but I'm not doing a proof, so I don't know. If you do a proof and you find out that my final solution, in this case, what's the final solution? The final solution is 2 comma negative 2. If you find that I've made an error somewhere because you did a proof and it didn't work out, if you contact me and tell me what my error is, I'll give you 5 points bonus on the quiz. Because sure, why not? I need to know. And if you're doing the proofs, good for you. So you're going to do proofs just to be sure. And of course, I'm not going to give 5 points to everybody. If there's an error, you know, the first person that writes me can also write everybody else and tell them. So I'm going to just leave it to you to, if you find an error, to contact me, and the first person I hear from will get those points. But there might not be any points available because I might not be making mistakes. So do the proof and find out.